Okay, what's up, guys? I'm back. Turns out didn't have office hours. That's all the. It was a different day tomorrow actually, so I'm gonna spend some more time here trying to go over. Uh, I guess some of the questions I missed during the exam. Yeah, this exam was so hard. I got a 42%, and honestly, I don't even know if I can get better than that. Okay. R I F. So you invented a new strategy and presented it in the meeting. Let the excess return of your strategy RIF. Your boss asks you to make your strategy market neutral in the sense of being uncorrelated with the market. How to do so? Show mathematically that your strategy is market neutral. So in order to make the strategy market neutral, must have a beta equal to 0. Okay, so mathematically that is, so I think we do RI E, right? Not F. Is, oops. Shit. Alright, I'm not entirely sure what's going on here. So RE is equal to RF. Or we could say alpha beta 0 plus beta 1 market risk premium RP, and maybe plus some epsilon I. Then such beta 1 is equal to 0. Okay, so beta 1 is equal to 0. How do you do that, right? So I think so beta 1 is equal to, we should before that it's equal to the sum so we have sum of I do I is equal to 1 to n of so we could do x, maybe I minus, so r x, and then we also want to multiply this by r I f e, so minus r bar r e. Okay, so it's the see, product of the differences between the micro returns and then the excess returns for our strategy. And so x I plus sum I is equal to 1 and xi minus, I think, bar x, all right, squared. So this is the sum of square residuals. And so this is actually equal to of RE. So we don't want this. Oh, never mind. We don't want this. There we go. Okay. In order for beta 1 to be 0, then xi minus x bar has to be 0. The sum of all xi, x bar is equal to 0. So what does that mean? Does that mean you go long when the market is greater than the beta and then short? So xi minus x bar, so this is the expected return, the market, or sample average of the market. This is the actual realized in the market. You short the beta I position of the market portfolio, that is the market neutral return of your strategies. Beta I position of the market, that is the market neutral return of strategy, is RIE minus beta I times REN. Oh man, not entirely sure what that means. How do you make your strategy market neutral so whenever the market goes down? Curious. How to make a market neutral strategy. Yeah, ask ChatGPT. So I think I have the right idea here. Oh my god. Alright. There is some mathematical complexity in this. Okay. I need to take a few seconds just to kind of recuperate, get the juices flowing. Also trying to find where my econometrics book went. See here? Nope. And here perhaps? Nope. Yeah, not entirely sure what that would be, to be honest. Oh, nope. Alright, let's try to do this and then go to the dining hall, then head out. So it seems like in order to make the market neutral strategy, beta must be 0. I think this is actually kind of false here, so just equal to 0. In order to make this strategy market neutral, I must have a beta 1 is equal to 0. Mathematically, that is. Actually, okay. We assume that, so, because Ri is not market neutral, that must mean it has some, so beta I that is non-zero. I E is equal to beta 0 plus beta 1 plus R M. So return to the market, I think to that as well. Maybe quad beta I not equal 0. Okay. So because the excess return on the market is not market neutral, that must mean it has some beta I that is non-zero. Okay, that's fair. All right, so if it has a non-zero beta I, oh, so I think the idea here is, all right, if we short this amount of beta I, So if we short the market by beta I, then that must mean this term kind of completely cancels out. And if this term completely cancels out, then we're just left with beta 0, so some type of alpha plus some error. A sneaky way to do this is to just short beta I amounts of the market, which will so minus beta I, RME, okay. So I'm gonna delete this actually. Comparing the covariance between the new market neutral strategy and the turns on the market portfolio show. So we have covariance of beta, so RM, RI, E, so minus beta I, we'll call this RM, E, and then RM. Again, ray, so this is equal to linearity of covariances. Covariances are linear, so does that mean we could do this? Covariance of RI E of RM is E okay. So we subtract beta covariance of right. Okay, so this is also exact same thing as beta times the variance of the market portfolio, x turns, subtract so the covariance between is actually M. So the market and the market itself is just exactly the variance scaled by some beta. So beta times variance of R M E is equal to 0. Okay. So maybe some notes. Again, ray, C, and ray. So text, how does actually specifically correlation of so covariance of so beta is equal to covariance of R I E. Okay, yeah, actually, maybe let's keep this consistent. So it's beta I. So this becomes beta I, and then beta I is equal to covariance of Ri. So the return of our strategy, and then Rm. Variance of Rm. So the variance of our signal here, which is the market returns, right? And so all we have to do is just move this over. So we have beta I times Ri, covariance of so by definition, so showed above that showed that our strategy had basically, okay, I think that's okay. So the big idea here is, in order to make our strategy market neutral, we just have to short beta I of the market. So this comes with the idea that beta 1 has to equal to 0, and so mathematically that means the x return of our market, or sorry, the x return of our strategy is equal to beta 0 plus beta 1 times the x return of the market plus some type of error. And because our strategy is not market neutral, that just means it has some beta I that is non-zero right now. So this is how we can kind of express the returns as a linear regression, or a linear model, and beta I here is positive or negative. It's just non-zero. So that means it has some correlation to the market. And in order to kind of remove this correlation, I think one of the ways we could do this is just subtract beta I times REM. So subtract beta I of the market portfolio, and that kind of just removes this term completely. And so now all of the return, the excess return of our strategy just depends on beta 0 and then epsilon I. So there's no more beta I anymore. Now, I think in order to show this pretty rigorously mathematically, we can compare the covariances between the new market initial strategy and the returns on the market portfolio. So in order to do that, we take the covariance of our new strategy, which is the excess returns of our strategy minus beta I times the excess returns of the market. So this is the shorting part. And then compare this with the returns of the market. And because covariances are linear, we can separate this into two terms. So the covariance of our strategy, covariance of the market, and covariance of the beta I times the market, and the covariance between the market. So this turns out to just, you can bring out the beta. So the beta is just scaling things. And this leaves us with a variance of just, this just leaves us with the variance of the market. And then this right here, this is the same thing as beta I times variance of the return on the market, excess return on the market. Beta I here is defined above as covariance of the return on our market, the excess returns on the market, and then the excess returns of our strategy. So that means beta I times the variance of covariance of the R. So that means the covariance of the strategy in the market is exactly equal to the variance times beta I. So what does this show us, right? So as movement between as let's say our strategy return moves in one direction, then that means the market portfolio tends to move between beta I variance of the market. So that means if this beta is less than 1, then the market tends to move a lot less compared to the returns. And then if the beta is greater than 1, that means the beta is greater than 1, that means, okay, so if the market has high variance and our beta 1 is high, that means variance of the market has a greater effect on the covariance. Okay. Yeah, I'll take this for now. I'll take this. All right. So I think this is one of the harder ones. I think I have one more that was pretty hard. Maybe two more. But I'll get back to those. I'm going to go to the dining hall and then meet up with Andre right now. So thanks for tuning in, and catch you guys in the next one. Peace. Oh, Andre, if you're still here, I'm about to go to the dining hall, and then hopefully I'll take like 20 minutes, and then I'll head over to McKellen. Alright, goodbye.